Hey there, Math Moment Makers. John here from Make Math Moments. And in this video, we are going to talk about how to sneak in linear relations into your classroom. So let's get into it. And if this is the first time you are here on our channel or our page or wherever you're coming from, be sure to subscribe here over on YouTube or hit the like button over on Facebook so you get notified when we put up new videos. We're actually putting up new videos every single week. So what I'm going to show you here is how I actually sneak in linear relations into my 9th grade course. My 9th grade course about it's a grade 9 applied program here in Ontario, and the program is right now it's mostly for kids who have been told that they're not so great at math, or have identified themselves or teachers have identified them not to be so strong in math concepts. We are changing that here in the province to kind of go away from streaming, or we're calling it de-streaming. But I've been sneaking in linear relations for the last few years into this course, and basically through warm-ups, I have been teaching almost a whole course or a whole section or a whole unit on linear relations without actually taking time to do a whole unit. We do it in chunks. So I want to show you that. And what you're about to see is a live lesson that I did with my students. I recorded it, but I also have edited it so that you don't see any faces or names, that kind of stuff. What you're going to see is my side of the recording and the screen. So it was completely remote learning style to introduce how do we teach some of the basics of linear relations. We do it through patterning. So I want to show you that. So stick around because I want to explain how you can learn deeper about what we're doing here in class, because we use something called the curiosity path in this video, in this lesson. I don't call that with my students though, but I did utilize that. And after the video is over, stick around because I'll show you how to make more use or learn more about it. A warm-up activity. So grab your pencils, grab your paper, and then remember, pin me so that I'm nice and large here. Here we go. I'm going to ask you to draw some stuff right away. Here we go. We're going to draw some stuff right away. In the past, we've shown you, maybe you've seen patterning. I'm going to show you some figure numbers. Here we go. Figures coming your way. Get ready to draw these, okay? So here, I'm going to give you some time to draw these as well. And then we're going to share them. Share those drawings, but also share your thinking on what you're seeing here. All right, here we go. Get ready. Get ready. Here we go. First drawing, okay? So first step, first figure in this particular pattern we're going to look at here. Here we go. Step 1. Oh, hang on. I've clicked the wrong button. Here we go. Step 1. Boom. There it is. Give it a draw. Draw that somewhere on your page as figure 1. Go for it. I'll give you a little time here. Now, as you draw, what I'm going to be asking you to do is I'm going to ask you to flip your camera on in a little bit, because I'm going to ask you to hold up your drawings into the camera so that I can have a peek. Okay, so get ready for that. I'm going to ask you to draw, and then you're going to hold up your pattern, that what you've drawn, into the camera. We're going to have a peek at the drawings that are coming out. All right, here we go. Here we go. Let's look at, get ready. Here we go. Get ready to draw figure number 2. Figure number 2 coming your way right now. Here it is. Figure 2. Boom. We're going to move a little faster here. Okay, you're drawing. You're thinking. Here comes figure 3. Figure 3. Here we go. 1, 2. Boom. Oh my goodness. What? Hey, can you guys predict on your page? Draw me what you think figure 3 looks like. Go ahead, draw it, and when you're ready, hold it up to the camera so I can see what you think figure 3 looks like. Go ahead, I'm going to give you some think time and also some sketch time. Go ahead, you got about a minute and a bit. A minute and a bit, go. Interesting, thank you very much, thank you very much. Get those cameras on, show me, here we go. Ah, very, very interesting, thank you very much. I love the drawings that just came in. Thank you for sharing. Thank you for being brave enough to share your thinking. I love that. Here we go. I'm going to show you now. I'm going to show you what I was thinking for pattern or step or figure number 3. And if you're matched mine, I want you to give me a hand raise in the classroom. Or in the meet, and if it doesn't match, that's fine, because I haven't shown you enough information yet, right? I've shown you some thinking, but if you match, I want to see a hand raise. If not, no worries. because there's nothing wrong with thinking. We've only shown you 2 out of 3 or 4 stages right here. Here we go. On the count of 3, I'm going to reveal stage number 3, figure number 3 that I was thinking about. Here we go. 1, 2, 3. Boom! All right. Hands down. Thank you very much. Hands down. Beautiful. All right. Who is also brave? Can I flip on your mic? I would love to hear your thinking on how this pattern is changing so far.
Each time they added 2 more circles.
Let me just repeat what you just said. You said each time they add 2 more circles. Can you explain where the 2 circles get added in?
So there's 4, and then they add 2 on each stem.
Okay, so there's 4. There's 4 here in figure 1. Is that what you're saying?
Yes.
Okay,
and
so
then add 2 to each stem.
Okay, so there's 4, like these 4 edges right here, like 1, 2, 3, 4, like I'm counting.
Yes.
Okay, and then you said they add 2 to that. Is that what's happening over here?
Yes, it's me.
There's.
Well, they add 2 onto this. No, sorry, they don't add 2. They add 4.
There's 4 added on. Is that what you? So there's
each time.
Okay, so let's check. Well, 1, 2, 3, 4 added on to those corners, and then over here, we've also got 1, 2, 3, 4. Put a hand raise in the Google Meet here if you also saw that exactly the same way. Okay. Anyone brave enough to explain how this was changing in a different way? They saw it slightly differently than what was just explained.
It was adding by 1 each time.
Can you explain more about adding 1 each time?
On all stems, it was just like adding by 1. Like at the beginning, it was like 4.
Yep.
And then it went up by 1 each time.
Gotcha. So I'm just going to compare the 2 explanations so far in this particular pattern. The last person, Jaden, just said that you were adding 4 each time, and 1, 2, 3, 4. There's the 4 extra, and then there's 4 extra added here. And I think what Austin's saying right here, Austin, correct me if I'm wrong on your thinking, is you're saying that there's added 1 right here. But you're also saying there's added 1 right here, right? And 1 right here and 1 right here?
Yeah.
Yeah, so we're adding 1 to each stem. I like how he used the word stem there each time. Anybody else see this pattern changing slightly differently? So that is an interesting difference, right? So Jaden has seen it like the whole thing is going out as like, boom, 4, 4, 4. Whereas as Austin is seeing, that's went out 1 more each time. 1 more, 1 more. 1 more. Interesting.
Miranda, not me.
Pardon?
That was Miranda, not me.
Ah, thank you for clarifying. Miranda. Anybody else see this changing differently? All right. Can you on your page now draw me what stage 4 or figure 4 looks like? Go ahead, draw me figure 4, folks. What's figure 4 look like? Hold it up to the camera. Make sure we're all on the same page here. Click boom. Boom. There it is. Give me a hand raise. Match. There they go. There they go. Okay. All right. You've done so far the easy work. Awesome. You have done the easy work. Here's what I'd like you to do. I would like you not to draw me figure 5. Or explain or describe what figure 5 looks like. We're seeing 1, 2, 3, and 4. I don't want you to give me figure 6. I don't want you to give me figure 7. I don't want you to say figure 10 or what that looks like. I want you to draw me what or explain or describe what figure 43 looks like. Okay, so we've done this like in the past with our submissions here. I want you to draw me some thinking on figure 43. What's it look like? We're going to be also talking about how many circles there are at figure 43. That's going to help you with what it looks like. And I want you to take a picture of your thinking and then send that off to me like we have done in the past. The instructions, again, are on the screen. I'm going to wait for those. I'm going to give you some good think time here. Figure 43, we're going to have, I'm going to give you a little shorter than yesterday. Yesterday we had some think time around 10 minutes. We're going to go 8 minutes right now on think time, okay? 8 minutes. Let me see them come in. Okay, so let's have a peek at some of the solutions that are coming in, the thinking that's coming in for what the figure 43 looks like. I'm also going to challenge you as we think here this morning on what a general formula might look like to figure out any figure number. Like if I said figure 100, we could use our formula to figure out how many circles are in figure 100. Or if I said, hey, let's figure out 1021, we could figure out using our formula what figure number 1021 is. Okay, so I'm going to challenge you to think about that while we're looking at some solutions here. Remember that these are not all the solutions. They're just a few of the solutions that we're going to have a peek at here. All right, so I'm going to bring this first one over. Here we go. This first one right here is, hang on just a sec. There we go. Wasn't just ready. There we go. This first one right here kind of has our first four pictures, the first four figures, and then I like that these words are describing what we just talked about before. We said, hey, look at there's stems, and then we've got one stem here, two stems here, three stems here. So I see some thinking here. Now I'm wondering if anyone wants to chime in of like why this 4 times 43 works here. Can someone help us understand that? Like, I see some good thinking here. I definitely see a lot of great understanding here on how many dots, but I'm wondering if somebody wants to speak to why we're taking 4 and we're multiplying it by 43.
Because in each stem, there's the n number. So, like, all you would have to do, like, in 4, there's 4 in each stem.
Okay.
So you times it by 4 and get the overall.
Got it. Okay, so let me just repeat what you just said. Is you were relating the stem to the figure number. So you said, hey, there's 4 in the stem here, and it's figure 4. Is that correct?
Yeah, there's like each stem has n number.
Ooh, I like the way you just said that. Did everyone hear that? She said, let me just draw this up on the screen here. I'm just gonna paste this right here on the screen. I like how that was said. That was said very nicely. Check this out. She said each stem has n number. If this is step 1, that's like step 1, step 2, step 3, step 4. There you go. You can see it a little bit better. Then on step 1, when n is 1, like any step, we've got 1 in the stem, each of the stems. And there's 4 of those stems. And on step 2, n is 2, like any step 2 is, there's 2 in each step. And there's 4 of those. And then on step 3, any step would be step 3. We've got 3 in each stem. There's 4 of those. And on step 4, there's 4 in each stem, and there's 4 of those. So one calculation on step 3 here, I think from what you just said here, is that there are on step 3 there are 3 dots on each stem, but there are 4 stems. And then looks like here we've got that. So this multiplying by 4 makes sense now. I think we've got the any step times 4 because there's 4. And then what's going on over here? Somebody want to see all of a sudden why 172 becomes 173? Why does 172 become one?
With the 172, they're not including the middle dot, and for 173, they're including the middle dot.
There's that middle dot kicking around, kind of like that constant one we saw yesterday, right? There's that constant one started yesterday. So if in my calculation up here, I've got 3 times 4 because there's 4 groups of 3, and then we have that 1 in the middle. On this one, we had 2 times 4, and then we had that 1 in the middle. And on this one, we really have one group of 4, like 4 groups of 1, 4 groups of 1, and then that 1 in the middle. And on this one, we have 4 groups of 4, and then 1 in the middle. And I'm wondering, this is some good thinking so far. So that now we can clearly see why we're taking 43, because on step 43, we would have that 1, and then there's going to be 43 on each step, just like that Jaden there. I think it was Jaden. Jaden, was it you that said that? Let me get that right this time, right? There was n on each stem. Yeah. Okay. So I want to show you another picture because a student drew exactly what 43 kind of looks like here. Let me show you another picture from one of you guys. Look at that. So there's that same thinking that on step 43, there would be 43 circles. Notice we didn't have to draw all the circles. It's very clearly articulated here that there are 43 out that way, 43 out that way, 43 out that way, and 43 out that way, and then 1 in the middle. And so you can see that calculation right up here, that there's that same 4 groups of 43, and then that gave us 172, and then we added that 1 in the middle. And I'm sure this meant to say 173 up here instead of just equals 3. Let me bring you another one right here. Here's another one. Check this one out. Same idea, but I like check this this representation out. Similarly to way Jaden said the stem. This student also used the word stem. That said, hey, there's one dot in the stem, and then there's 2 dots per stem, 3 dots in a stem, 4 dots in a stem, and therefore there's that same picture. There's 43 dots on the stems. And therefore, we would have, I don't see a final answer here, but they've definitely shared their thinking on what it would look like. Awesome stuff there. I'm going to challenge. Anybody want to come up with a formula here to help us out? Like, what would the formula be if we used what Jaden said, n for step n?
4n plus 4.
4n plus 4. Okay, let me just write that down first. You said 4n plus 4. Can you just walk me through again where the numbers come from? Like, how does it relate to the pictures above here? Help me out.
Because each time 4 get added, you start out with 4 and 4 get added each time.
Okay, so I'm seeing lots of 4s. Can you tell me which 4 in this formula represents the 4 being, the 4 stems,
The one before the n?
The one before the n. So this is saying, like, I've got 4 groups of, let me just highlight this a little bit deeper here. So right here, we've got 4 groups. Four groups of, like, of n, right? Of n, of the stems. Okay. We get that. I think that makes sense. We definitely, if you look at my calculations up here, we definitely multiplied n by 4 every time. Like, every time n was a number, we multiplied it by 4, just like you did. Can you tell me now what this 4 means?
Shouldn't it be plus 1?
Why should it be plus 1 instead of plus 4?
Because the dot in the middle.
This is the dot in the middle. This is the dot in the middle. Plus 1 right there. So we've got the group of 4 right here, and then the 1 in the middle. And notice that matches the same calculation we were doing up here every single time. We were multiplying by 4, and then we added 1. And all we're going to do is we're going to substitute n in there for our step number. So I could write a formula here that says, circles, the number of circles equals 4 times n plus 1. And that represents the number of circles at step n. Now, so if I use my formula right now, check this out. It's going to match your solutions here. So the circles would be 4 times 43 plus 1. We've seen some calculations from our friends here that 4 times 43 was what, 172, and then we add 1 more, we get 173. Give me a hand raise if you also got 173 in your calculations here for how many circles would be on step 43. Okay. I want to extend this just one more, talk about one more strategy here that we have not really discussed yet. So I'm going to go back to this picture here. I'm going to show you some similarities with what you guys have done and something that can help us stay organized. Sometimes mathematics we want to keep organized, and we can do this. Yesterday I kind of showed you this T-table, this chart, this table of values. Do you remember that? We looked at that. We can keep organized because some of you started that way too with the table of values yesterday. If I keep track of step or figure number here, and then this time we're tracking circles, I can do that here. On step 1, we had, how many circles on step 1, by the way? Like, 1, 2, 3. There's 5, right? There's 5 circles there. And then on step 2, how many are there? If we count, right, there's 4 groups of 2, and then we add 1, so that's 2 times, that's 8, and then plus, wait, that's 2, 4, 6, 8, plus 1 more is 9. And on step 3, there's 4 groups of 3, that's 12, plus 1 in the middle is 13. And then we've got step 4 here, which would be 4 groups of 4. 16 plus 1 in the middle is 17. Does anybody see the pattern in the table? What do we see from here to here? What do we see? Do you notice the similarities with your solutions and what we're seeing here? Do you see a common number? What's going on here?
We go up by 4.
All right. There's by 4 right here, right? And that's that. In the beautiful part about seeing it this way in the table as well is that 4 mimics the 4, right, that we were talking about being added on to the corners here, right? Remember Austin said you add 1 to each corner, and then another person had said we're adding 4 to each one. Like that's mimicking right here in this number table, like the numeric representation of this pattern. Okay, now, so we've got this nice organized way, and if you're going to add 4 every single time, you know, if I need to get up to stage 43, which is way down here, right? Stage 43 is way down here. Well, why would we want to add 43 each, or add 4 each time? Why don't we speed that up, right? We'll just multiply by 4. That's the same as repeated addition up to 43 times. So if we add 4 all the way up to 43 times, well, that's going to speed up the calculation. And that's mimicking the work we did back here, right? We multiplied by 4 because we were adding 4 every time. That was partly why we did that. Now, here's the thing. If multiplying by 4 is the rule, and we know it's not because we've already talked about the formula in the rule, and then this should work out every step. Like 4 times 43 we said was 172, but if all you had to do was multiply by 4, it should work on this step. Look at this. Take step 1. What's 1 times 4? I'll do that one. 4. But we have an answer of 5 circles, so we're off. On step 2, well, if you just multiply by 4, you get 8. But there's 9, so we're off. On step 3, if you just had to multiply by 4, you would multiply by 4 and get 12. But we need 13, so we're off. What are we consistently off by?
Each time you times by 4, but then you add 1.
You gotta add
the middle circle.
You gotta add that 1. That's that same. You can see that same strategy has to exist here in the table. We gotta add that 1 because if I just multiply each of these by 4, it doesn't work. I need to get these numbers exactly. So that's how we get 173 as well over here. It's 2. Now we've seen 2 different ways. You can see a visual way on how to create this formula, which is 4 times n plus 1 for the number of circles. Or what we can do is we can use a table format to organize our thinking and also see that same number pop out here at 4 and then use some thinking to find that plus 1, that constant, that offset. And tomorrow we're going to look at another place where we can see that offset, or tomorrow, the next time, we'll see another place where we can see where that offset comes in. It's actually hidden in this table right here. So we'll have a peek at that. All right, thank you to everybody who has sent me the pictures, and I can check your name off on all of that things. Is there any questions about what we've done here? Okay, Math Moment Makers, thanks for checking out that video. I hope that you saw some of the kind of teacher moves that I was making while talking with my students and introducing the ideas of linear relations without actually going into too depth, like overloading them with linear relations, because we'll do that process. We'll do that warm up with different patterning problems and slowly build in how to build linear equations. You saw us start that here in this video, but also how to relate, say, finding the y-intercept to the table of values, and we'll eventually solve some more complex problems. Like we'll all of a sudden skip some patterns, like all of a sudden we have to now introduce rates of change. So I sneak that into the course by just doing some 10-minute, 15-minute, sometimes it takes 20 minutes. This one was a little longer because it was early in the course. We sneak that in early, and then basically we don't have to teach a whole unit on linear relations. We've already done it, and we're ready to just kind of like extend some thinking on it. I did say that at the end of the video, stick around and you can learn more about the curiosity path. You can do that over at makemathmoments.com. Hit that website, our website, to see lots of resources we have about that. But I do want to point out one main resource. We have a 12-week full program on making math moments that matter. We call it a full workshop. It's a 12-week program, And in there, we talk specifically about how to solve problems or how to teach, make your textbook problems more engaging. I'm just going to open up module 2 from that full 12-week workshop here and show you that we've got how to transform textbook problems into captivating tasks. So I use the curiosity path. We teach all about the curiosity path in module 2. But we talk about the curiosity path and how to withhold information. You'll have noticed that I withheld a lot of information in this video about the pattern. And so we kind of talk about that in this module lesson. Actually, this is only just one lesson of the module, which is one module in the 6-module course. So we show that ins and outs of changing your textbook problems over there in that course, and that's, as I said, just one lesson out of many lessons in that course. We teach the whole program of how to use our 3-part framework for building lessons that kids don't want to stop learning, and how you can make math moments in your class. You can learn more about the workshop by heading over to makemathmoments.com/online workshop. Up here, I can just zoom in here. It's like this is what the page would look like. Make Math Moments online workshop here up in the top corner. And right now, if you're watching this video the week it goes out, we are open for registration on that workshop right here. Okay, so we've got we're open for the summer cohort, and really looking forward to welcoming a good group. We've already got lots of folks registered for this. We've had 1,000 teachers through this program in the past couple years, and really looking forward to getting started again with this summer cohort. So if you want to learn more about the 3-part framework and the curiosity path, then we suggest you check that website out here to register the 12-week program. But thanks for watching, and if you have not yet subscribed, please subscribe over on YouTube or hit the like button on Facebook, and we'll check you in the next one.